Hello everyone, in this class we are going to start with time complexity of an algorithm. That means we will see how we can find the time complexity of algorithms. Now let's start. So we have an algorithm and for this algorithm we need to find the time complexity. Now, the first thing that comes is this algorithm. We can implement any algorithm in two different ways. That means two approach can be used to design any algorithm. What are those two approach? The first approach is called iterative approach. Iterative approach, and the second algorithm is called recursive approach. Now, what is iterative approach and what is recursive approach? So, let's start with iterative approach. So, in case of iterative approach, iterative approach for algorithm. Now, in case of iterative approach, we will use loop inside algorithm. Now, and what happened in case of recursive approach? In case of recursive approach, we will use recursive function. And now, how to find the time complexity for an algorithm that having iteration or loop, and how to find the time complexity of an algorithm that has recursive function implementation. So now we all know that in case of recursive function, the execution is performed based on stack concept. Clear? Now to find the time complexity in case of recursive function, we have to know we have to find the recursive equation, and based on this recursive equation we will find the time complexity of an algorithm that has recursive function in it. Now, in case of iterative approach, how we can find the time complexity? In case of iterative approach, we will count the number of iteration that will execute. That means how many times the loop will execute, that number we have to find in case of iterative approach of algorithm. And in case of recursive approach of algorithm, we need to find the recursive equation. And based on this recursive equation we can find the time complexity for that algorithm. But in case of iterative approach, we will count the number of iteration that the algorithm will execute. Now what happen if any algorithm don't have any iterative approach and any recursive function? Then what will be the time complexity? That means if if algorithm don't have what iteration as well as recursion. What will be the time complexity of that particular algorithm? Look, as there is no iteration and as well as there is no recursion, the time complexity of such algorithm will be constant always. That means the algorithm will take only a constant time to perform its execution, to perform its operation. So how we can represent the constant time? We can represent the constant time complexity by using big O of 1. Whenever any algorithm takes or any instruction takes only a constant time, at that time complexity will represent by using big O notation and 1. So this thing is also equivalent of big O C, that means constant time. Any constant time we can represent in two ways, that is big O of 1 or big O of C. Clear? So, and that is when the algorithm did not have any iteration and recursion in it. Now, next thing. Next thing is we will start with iterative approach. After that, after completion of iterative approach, and then we will go for recursive approach. Next, let's say we have an algorithm like function, and within this function we have just one statement, that is print A, B, C. Look, in this particular function we don't have any iteration as well as any recursion. That means we don't have any loop as well as any recursive function. We have only one statement, that is print statement. So what will be the time taken by this statement? The time taken by this statement is only a constant time. That means this will take a constant time. So how to find the time complexity of such a problem or such an algorithm? And time complexity we will represent by using a function called t and n. That means n is our number of input. Look, here we did not have any input. So what will be the time complexity of this particular algorithm? That will take only constant time. So big O of 1. This is the time complexity of this particular problem, where we don't have any iterative statement and as well as any recursive statement. So now what happens if there is some more statement is there, like integer x, y, x equal to 10, y equal to 20, integer z equal to x plus y. Now what will be the time complexity of this particular problem? Look, here the first statement, this one is not loop, not recursive, that means it will take only a constant time. This is again no loop, no recursion, so it will again take constant time. This statement again it will take some constant time. This statement again it will take some constant time. This statement again it will take some constant time. But are all the constants are same? No. So because of that we use C1, C2, C3, C4, C5. So what is the total time taken by this particular problem? That is, total time is order t of n, and that is C1 plus C2 plus C3 plus C4 plus C5. Now if we add all the constant, again we will get a constant only. So let that constant is C. Now whenever we get any constant time complexity, at that time how we can represent it? We can represent it by using order of 1. Look, this one is big O. Big O notation is again called as order of 1. Clear? So hope you understood the concept. Next,